paper since been renamed, why is anything conscious, preprints available, and Sabine Hofstede just did a video on it, which is quite a So, I'm going to conclude that zombies are impossible. And to do this, I'll present a model of consciousness. And it unifies lower and higher order theories. The summary of the argument of the course of the presentation is sort of, first I'll argue we should start with the embodied organism and natural selection. Then I'll build on a formalism that I've been developing over the course of my PhD called pan-computational activism. It's sort of a formalism of all conceivable environments. And I'll argue that systems self-organize to interpret unlabeled sensory information according to methods, and that these interpretations imply behavioral policies. I'll argue these policies can only really be differentiated from each other by this is unlabeled information, and the policies themselves are labeled. The unifies lower and higher order thought theory. And then in that context, selection pressures can demand a policy that classifies an organism's own interventions. This is akin to reafference or the proposed do operate. And because this accompanies every action an organism takes, and it has a quality in the policy in the system, it is what it is like to be the organism. So I argue this is where phenomenal consciousness begins. And then I'll argue that a consistent definition of access consciousness should be information available for meaningful report, not just report, but meaning in the sense described by language philosopher Grice, which involves inference of intent and modeling what you think, I think, you think. And as a result, I'll argue that we can't have this form of access consciousness without phenomenal consciousness as described here, and so a zombie is impossible in all conceivable environments. So why start with the embodied organism? Well, we have to start somewhere, and people have made a lot of progress starting with the mind already. But taking this approach, we look at something like higher order thought theory, and you know, it does a great job of distinguishing between why some information is in the light of consciousness and some in the dark, in that that information is that is in the light is a meta-representation of lower order thoughts. But it doesn't really explain why anything needs to be in the light at all, why anything needs to be conscious. So where do these lower order thoughts come from? And I suppose there is something like an abstraction layer or an interpreter, and we'll come back to this. In computational terms, you can think of wanting an embodied formalism to, instead of having the environment as something outside the computer and the mind as software running on the computer, we want to move the interpreter outside so that we have the environment and mind as software in a way together. So that the embodiment is part of the everything from scratch. I'm using software here as an analogy, not literally software. Alright, so this involves unifying pan-computationalism and an activism. So pan-computationalism is the idea that everything implements a computational system. Now this is very, we're using a very basic mechanistic definition of computation here, which is basically cause and effect. And in activism is the idea that the mind is part of the environment, the boundaries of interaction of the body. That's a loose interpretation of it, but for the purpose of this presentation. So how do we go about embodiment? Well, for all conceivable environments, we'll work from two axes. The first is where there are things, we call those things the environment, and where things change, for example, over time, you have different states of the environment. So different states might represent different points in time and different points in space. And we also assume, for the sake of simplicity, though this isn't needed for the unconceivable environments thing, that we have spatially extended environments. This just makes it a lot easier because we can now deal with finite sets, because we've got, you know, a finite amount of information to be contained in a bounded system. Now, I won't go into the math. There are lots of math definitions. To explain a little bit of how this is formalized, though, we've got this set of states, and we can say, well, every subset of states is like a respective fact. It is a program, and the states in which it contains are like the true conditions of that program. And so we can say the power set of all states is the set of all possible declarative programs in this environment, whatever that environment is. And we might have infinitely many states, so the power set of all states would possibly be has a ribbon of pan computational time. Now, every aspect of the environment would then just be another set of states. And you can see here, so two programs might be true in the same state, in which case the particular aspect that contains the two programs would be realized by that state. And other programs would be completely disconnected from that. And why this is useful is because it means that any set of programs allows us to kind of implement a formal language. And we have true conditions determined with respect to states. We have implication because every true statement implies every subset of the sum. And we have negation because some states are mutually exclusive. We can represent, something is, there's going to be the opposite of something that's all true. There's going to be something that's all false at the same time. And this means an embodied organism implements language. And a story, how a story starts constrains how it ends. And so we think of this embodied organism, which implements a language, as constraining itself by making any statement in this language. For example, if I lift my arm, I'm making a statement with my body in this embodied language. It constrains what else I can do next. So this could be an input to starting a situation, and output is whatever I choose to do next. And so we can now frame this in terms of inputs and outputs, and we have this idea of an embodied task, which means we can talk about learning and application. So assume, for the sake of argument, organism might encounter, a set of inputs or I. All possible inputs this organism might encounter, and that constrains the organism to a set of possible outputs given those inputs. Now, only some of those outputs are going to be fit according to natural selection. Not everything the organism might do is going to preserve its existence or preserve its so I can describe every organism basically by the extension of fit behavior of that organism, and that gives me this task, a set of inputs and outputs. And when we've got that set of inputs and outputs, we can say, well, that's what we want to learn. That's what we want the organism to adapt to. That's the target of, its survival. Our body can constrain possible outputs by making a statement, as I said, but when such a statement is not an input, we're calling a policy. This is, and the point of learning and adaptation is the organism wants to embody a policy that constrains its outputs to fit outputs. So you can see here, we have an input X, the possible output given X, and there's a language the organism's body can express. Now it might express another statement, policy, Y. If Y is a fit policy, then it can constrain the possible outputs given X to fit outputs. And the organism's past is like an extensive definition of fit behavior if it's still alive. And so this is like training data. The organism learns policy. So you can see, you can have historical examples of fit behavior, the organism's experience, and as it learns, it can piece together all fit behavior, assuming it lives long. Many policies can be learned from extensive definition. So, see here, I've got one of these, this is like an extensive definition. I could come up with many different policies, and most of them probably not going to fit. So, which policy is most likely to imply fit behavior? Well, this is a computer science problem. Previous research is formalisms of general intelligence, and this is essentially an alternative to the minimum description learning principle. Experiments outperformed minimum description in learning binary addition and multiplication in just predicting constraints. This improves the optimality, and this relates to theoretical models of superintelligence, which is the core of this. There's also a somewhat provocatively named paper put out last month on this, basically trying to explore why minimum description length and complexity still conveys some ability to generalize numbers. But to describe a little what I mean here, Weaker, less specific policies, it's like you don't, it's like a lawyer who doesn't provide any information he doesn't have to. He's saying as little as possible so he doesn't incriminate himself. Stronger, more specific, it's like you're arrested, you have viable diarrhea, volunteering information that might get you in trouble. Now we get into how this relates more to consciousness. The tasks are like PSCN triadic symbols. You have inputs, outputs, and policies. So you might look at this as tasks are like symbols, and efficiency demands on this and realize relevant symbols. This relates to the inactive notion of relevance realization. So you might smell coffee and want everything is inherently dispositional because it's a task. It's not just quality by itself or anything like that. Although I'll get into what I mean by these words like quality here. For now, what we're concerned with is causality. So which symbols are relevant? Well, when we learn policies that classify the unlabeled sensory information that causes valence. For example, why this notion of causality is important. If we look at it from a purely Bayesian perspective, we might have Bob could observe that rain causes Alice to put on a raincoat. Bob might conclude, based on this, that putting a raincoat on Alice will cause it to rain. But this is obviously not true. This just means that Bob's causal graph is incomplete. Bob needs to add a variable to Bob's graph to account for Bob's actions. So human level adaptation obviously involves the ability to learn causal graphs. We don't just start with them. And ultimately, sample-efficient learning has to be causal, whereas DeepMind recently put it for robust agents learn causal graphs. Now, if those optimality proofs that I mentioned before about policy optimization hold up, then that means that you should effectively learn the cause. So there's another paper on how you might do that, how you would learn what I call a causal identity for intervening agency by adapting to the environment of existence. And so when I'm saying realizing relevance, what I mean is an organism classifies intervening agencies. That includes other organs or projects. You're just learning a set of declarative programs that describe whatever it is that's causing what is implying the thing that you've observed. Now these causal identities are obviously, you can only learn so many. It's determined you've got finite memory, you're embodied. So what might these sort of things be? Well, it's like very specific, like a particular identity of a particular animal. Something less specific, like idea of dogs, something like friend and foe, and something even more general, like safety and eventually just behavior. It's sort of like in mathematics, it's a lattice of tasks. You're generalizing from more specific things to less specific, which brings us to qualitative information processing. So, causal identities are these interoceptive, exteroceptive classifiers. What do they classify? Well, I keep using the word unlinked information according to valence and specific needs. And so these policies are both dispositional and qualitative classifications. But this, I've still got an abstraction there, I've still got an embodiment. But this abstraction laid out is the product of natural selection, and that's important for a couple of assumptions. And this is where it relates back to the AI research. Another provocatively named paper from last month argues that the idea of software mind has a flaw. And this relates to specifically a formalism of general intelligence called types, which is a complexity-based general reinforcement learning agent. So we have a bit of that. What software does depends on how you interpret it, and interpretation is disposition. So typically AI is sort of as a software mind interacting with the world through interpreting. But this causes a couple of problems. Namely, to that aforementioned formalism of superintelligence, it means that every claim you might make about the upper bound or its its ability to learn environments and maximize reward is subjective. It's a perception of complexity, has to match some objective notion of complexity to remain optimal according to Occam's razor. And this means that it has to sort of match some objective UTM. So that undermines a lot of claims regarding this particular theoretical agent. Still, that is what that's what we're doing. A lot of our PhD research is trying to address that problem. And one of the side effects is that if you presuppose the world is divided up into certain objects and certain primitives, it can lower the sample efficiency. It can hinder your ability to adapt because you've essentially stuck within the world for a certain template. So taking it to its extreme, this has even led to people characterizing software as immortal. Hinton talks about immortal computations, and subsequently, Christian and Robia and Johannes have talked about mortal computations. Now, I am very much on the side of mortal computations, but not quite for the same reason that are in the papers. In fact, I would say that there's no such thing as immortal computations. That every piece of software is running on a piece of hardware. The reality is that software is a state of hardware. And the distinction between hardware and software, while very useful for making standardized products and so on, is a little bit reminiscent of circular mind body, which is why that provocatively named paper is called computational rules. If you think of interaction skills as mental and physical substances interacting through the pineal gland, this is like software and so a software mind interact with the environment through hardware. So the alternative, that is why I had to start on the outside and work my way in to get an upper bound of intelligent behavior. And that is why I had to move from this environment interpreted software mind to interpreted environment mind formalism. And now we can formalize the abstraction layer from the lowest possible level. So what would it be in a naturalist context? Well, biology is adaptive down to a very low level, and it's much more sample efficient than the current approaches to machine learning. It doesn't have a fixed high-level abstraction layer like x86 or Python interpreter. In this sort of, I would say that if there is a very basic abstraction layer we can point to, it's just attraction and repulsion in a physical system. And that means that interpretation is kind of motivated and dispositional at every level. You think of it as selection informing abstraction and death grounding meaning. And so then, if ALS is this sort of low level of abstraction, then you can think of quantity as something that is like a policy for interpreting information, and rather than the foundation. And when we say qualitative, what we really mean is just unlabeled information. And the only reason we think we can sort of conceive of non-qualitative information is because we get so lost in these high-level abstractions we build, but they're effectively, interpretations of this lower-level unlabeled information. So quality precedes quantity in this sense, and the foundation is just attraction and repulsion in a physical system. So policy is labeled and unlabeled. An organism's history implies a sort of lattice of tasks, and this unifies these lower and higher order representations, which brings us to order of self. Now, I've got two preconditions for reference. You're not going to learn all causal identities. You need to have your embodied language needs to be a sufficient scale to actually express the causal identity, and then there needs to be an evolutionary incentive. So, in the context of an organism surviving in the environment, it needs to be able to classify its own interventions at one time. This is like Close do operator or reafference, as Merker and subsequently Barentine have argued is related to subjective experience. I'm making a slightly different argument from that as to why this is related to subjective experience. Because I'm saying that this is every intervention I make is this policy accompanies every intervention I make, every action I take, everything associated with my sense of agency. And because policies are differentiated with quality, this policy is what it is like for me. And then, so we've got, at that point, something it is like. But is that, and it's functionally necessary for, the human level adaptability. I mean, we certainly need reference to reason about the impact of our actions. But is it, this is only still conceivable, this is really satisfying. Yes, not really. So look at access consciousness as well. conscious report should mean meaningful report in the sense that humans have. Well, according to the language philosopher Bryce, it's not just truth conditional semantics, but intended meaning, which requires that I need to be able to infer what you think. I need to be able to, and what you think that I think. And also that you know that I know something of what I think. So, if you think about it, this is a second order self. If we just continue to scale it up, add the incentive, then the second order self is my prediction of your prediction of me. So I need to be able to predict you to in enough detail that I'm predicting you predicting me, and then I'm predicting my prediction of you as part of that knowledge of reason about your intent that I infer something. So you can think about this as what you think I think in as much as it affects my goals. So you can intend that I believe something. I can infer that you intend that I think something by predicting the prediction of me and predicting that you also have a prediction of my prediction of you. I'll leave that something weird. But the point is that a consistent definition of access consciousness should require meaningful report. This says in clear, rigorous terms how you would be able to infer intent. And so, access consciousness you should only be considered to exist in second order selves. But how am I going to make use of the second order selves if I don't also have a first order self to reason about the effect of my actions? So you could say that conscious access in the sense of meaningful report. I've got to stop now?
No, well, you can run into questions on if you like.
Oh, yeah. Alright. So conscious report, conscious access depends upon both the first and second order self. Human level functionality is impossible without phenomenal consciousness, and you can't distinguish your own information and space effectively. Alright, so you need both first and second order. Without this, zombies are going to be impossible. You can't just have second order and expect it to function as a human being. And additionally, this also shows that zombies are inconceivable by showing how qualia can be inherently dispositional, which relates to God's argument as well. So there's sort of two ways to address this article. You can also use this to explain different evolutionary stages of consciousness, from flies, as Aaron and Klein have written about, to second order selves of access consciousness, and third order selves, which would be meta self, when being aware that you're aware, which is an internal stage of layers and everything else going on. Now, this is a formalism into which other stuff can fit. This is not a computational model in the sense of like a machine will describe. This is like the boundary conditions for stuff. Presenting this again in Lisbon in 2 weeks. We'll hopefully refine it a little bit by then because of the feedback from today. And the preprint is available. Now I can
when you are talking about software, you have, I think, two very conflicting notions that we're talking about, which leads to tension in the argument. One is the treat as code plus an interpreter. And the other one is the course structure that is actually acting on some kind of state vector. And so the computer in a former notion is a causal insulator. You have a physical universe that does all this thermodynamics, and on top of this you build a system that is so stable that it runs regardless of what the universe is doing as long as the computer remains intact. Right?
Yeah.
And at the same time, so this software is somewhat subset independent, subset agnostic. And yet it's a causal structure that is actually physical and that is working in physics like quasi-particle. And I think you need to resolve this somehow, because if you treat them as if they are the same, and you are switching between those contexts here. I have difficulty with the notion of modern computation. It seems to be empty to me. Computation is computation. Biological systems can be repetitive if they want to be, and algorithms can be self-modifying at every step. I don't see any fundamental difference. I see that the purpose of intelligence is not repetition, but exploration of new regions of behavior space. And consciousness is arguably at the forefront of this. But I think that the notion of modern computation, I don't really see how it helps. I think it obscures something. It obscures the generality by introducing a difference that doesn't hold.
That's fair. Particularly that last point, I guess that was what I was trying to get at, the computational dualism thing, which is that that I don't think immortal computation exists, so everything is immortal computation, so everything is just computation. You're right. As for more clearly talking about the computer as like a causal isolator, I think I can definitely clarify that, particularly with respect to the abstraction there and why, it being a product of natural selection carries certain length. Well, it means we can assume a couple of things about it being suited to its environment. And then, yes, causal isolator is a nice term.
Hi, thank you so much. It was a very interesting lecture, and I really liked the reading of your framework. My problem with it is that I didn't see the white slides we were talking about. So I can process information, I can integrate it, I can have even a self-model arguably and make predictions. That doesn't explain why I have the sensation, the pleasant sensation of smelling the rose outside in the garden. Like, I don't need that to be fulfilled in your framework. So I don't see so much how consciousness fits in here beyond processing.
I come back to this slide in particular. Now, the organism definitely needs to sort of, I would say that the idea that you can process that sort of information without, in something as light is sort of the case that you can't see the forest through the trees. We're making a big assumption there about the world in representation basically. And that's why I say a quantity is a labeled piece of information. And what we're dealing with here is unlabeled information. And when we do something like smell the rose, we are coming up with a label.
I'd love to discuss it later. I don't want to stress out the organizer. Thank you.
My question is, I wonder, do you think the first order, what is the likeness in the first order cells is kind of inherently consciousness? Or like, mainly I mean that do you think the first order cell and its functionality to access is inherent to consciousness or something that is more basic than consciousness? So because if it's not inherent to phenomenal consciousness, then we might still have access, the functionality of access consciousness without phenomenal consciousness per se. So I'm still kind of holding on that idea that maybe that will be the case, and we might still have the functions that we need without consciousness.
The key thing here is that the zombie behaves exactly like a human, which means it needs to adapt as efficiently as a human. Now, we could always make something behave like a human and find something transparent by just having enough data with no consciousness. It could just be essentially like a recording. If we want the sort of actual human level adaptability, then we need to have that first order self and second order self. That's not to say that we couldn't, construct something that has something like access consciousness. It's just not going to be as adaptive as it. And this last slide, like when I say a first order self is kind of where phenomenal consciousness begins. With Baron and you're saying it's like really basic, like fly. And then I would say that as Blocker argued, phenomenal and access consciousness can be intertwined. You can affect what sort of phenomenal experience you're having as you move up this phylogenetic.
Maybe a very stupid question, so but it's just how we guess it's a stupid question. But presumably what distinguishes conscious labelling of unlabeled information from a zombie is that it's in that labelling, the eventual label is indeterminate in principle. Do you agree?
If I understand,
If whatever policy is determining the labelling is indeterminate in principle, and if so, what is the principle?
I would hesitate to. I don't fully understand the question. I think that when you say indeterminate in principle, I'm going off in strange directions. But I guess, it wouldn't be so easy to point to your own classification.
It's indeterminate.
I guess. Maybe
Indeterminate how a system will label unlabeled information.
indeterminate.
No, outside.
Or like if I was outside and looking at the system, it'd be very hard to.
In principle, it's indeterminate. Otherwise, consciousness is relative autonomy is always possible.
Well, I mean, only if you're like outside the universe and trying to control every aspect of reality. This sounds like a big debate. Maybe let's talk about yeah.
Thank you. So we're going to go pretty much straight into